malware articles. I'm not showing how to make malware, but just analysis of the malware. Okay, also write some articles in our blog post that is actually the sales pitch, and then that's it. No more sales. I they made me one of the advisory committee of DEPCAM that is in a Romanian conference. Okay, most of the time, I use the other picture as my profile pic, but this one is the preferred version. That's how I feel when I do analysis, malware analysis. Okay. And those are some of the conference that I've been with. And sorry, Sekti, I put it's on the lower part. How many of you have seen a floppy disk? Don't be shy. My favorite one is the 3.5. Okay, during my university years, because that one is not too floppy. It's called floppy disk because you can actually bend it, and then that's it. But the 3.5 is actually harder than the other one. Okay, but looking at this picture, okay, it is actually a 1 gig storage device, but it is also 75 pounds. You can imagine a 1 gig that you can put in your key or in your pocket, right? So it's like during that time, you should be very, very strong just to carry a 1 gig in your pocket. But now, okay, you can buy this guy, which is actually 256 times of this, but a bit smaller, right? You can now carry more than that. You can even carry probably 1 terabytes of that 75 pounds equivalent. Anyway, I just mentioned that because we're going to look into the boot sector of those things. Okay? Even if you're using a floppy disk or you're talking about a hard drive, they both have a boot sector. Boot sector mostly is the very first sector of your drive. So if you're talking about the floppy disk, the very first sector is actually the boot sector. But if you're talking about the hard drive, there is what we call the MBR, the master boot record. Okay, so but the very first one, okay, for the hard drive is actually the MBR, and then each partition, actually the MBR only can contain 4 partitions at any given time. And then they can have your own different boot sector, okay? And we usually talk about the cylinder, head, and sector. Okay, so that is 001 for the MBR and the boot sector. How do you create an MBR? And what is a GPT? There is now a new version of partitioning for your hard drive. Okay, of course, probably you already know them. Okay, for the MBR, the very first sector is the master boot record. You can create 4 partitions. For the GPT, it is mostly used by, if you're trying to use the UEFI, mostly new computers now, they have the UEFI, then you have to create a GBT, GUID partition table. The main difference of those things is, for GPT, you can create many, for MBR, you can only have, you are limited for 4 partition. Okay? If you want more partitions, you have to create logical partitions for the MBR. But for the GPT, you can create as many partitions as you want. Okay? And of course, for backward compatibility, the very first sector is now called protective MBR, but still an MBR. And the second sector is actually the header for the GPT. Okay? Actually, there's another, the second and the last sectors are actually the GPT headers. Okay? If you're going to use a tool called disk management, it is available for Windows. Okay, you can create a partition or a disk. You can initiate your disk as MBR, or you can initiate a disk as GPT. Okay, you can select whatever you want to do. But if you happen to change your mind in the middle of your computing, okay, you can convert the MBR to GPT, and you can convert your MBR to, or GPT to MBR. But there is a risk. If you already have put information or your data or your pictures your videos in a certain disk partitions or this or different disk. For example, you have the MBR, and then you decided to change it to GPT. There's a chance that you will lose your videos, your pictures. So just be careful. Okay, let's show now how those things are separated. So this one, for this one, I created an MBR version disk. Okay, so you can see that I only have 4 partitions. Okay, this one is actually one partition, but different. It has different logical partitions. For the disk 2, okay, you can create as many partitions as you want. Okay, before, we usually have partitions in order to make your processing faster. But nowadays, because you have a faster machine compared to the like 10 years ago, okay, your machines is faster now. So basically, you don't actually need to make partitions. Actually, my computers at home, I don't usually use partitions anymore. But it's still up to you, right? For fun. Okay, so this one is the 4 MBR primary partitions, and these are the logical or extended partitions. For GPT, everything is primary partitions. You can still create logical partition if you want. Okay, there's another tool in Windows. You call that the disk partition, this part. Okay, if you run it, if you found this asterisk, okay, that means it is a GPT. Okay, those are just the different tools that you can check if you want to check if your hard drive is partitioned as MBR or GPT. Okay, what are now the differences? Okay, for MBR, we call the sectors in cylinder head sector addressing, CHS. For GPT, we call them LBA, okay? Logical block addressing. And of course, you can have a partition, you can have the table for conversion of the computations, okay? Why are we talking about those things? Because of this guy. Have you heard of Petia? It is actually derived from a movie, James Bond movie, okay, the satellite thing. Okay, it's called Petia. But this guy, we're going to talk about the Petia ransomware. Okay, execution flow. Okay, the new executable image, when you execute that one, there is this list of instructions, okay, just to decrypt a D word, 4 bytes. Okay, you will execute this one. If you're trying to do a reverse engineering of this malware, the very first thing that you will encounter is this set of instructions, and then you only get a D word. You will go back, execute again these things to get to decrypt another set of D word until you finally decrypt the whole Petia code. Okay, that is that version. Okay, so this is that particular code. Okay, you will know that you're already done decrypting the Petia code. Okay, if you can see now the header MZ and the PE, then you already have the disk image. It is not dropped. Okay, so the very first thing to execute a new image is actually to get the API that it needs. Okay, so for Petia, it actually gets the get proc address, load library, virtual address, and then after that, it will gather and grab all the needed APIs in order to execute its functionalities. Second one, it is going to look for .xxx, that's for X section. Okay, so that's the name of the section in your code. Okay, so this one. Okay, but you can see here, it is now actually a part. It is part of the decrypted code. It is now part of the. Can you see this information? It is the ransom note. Okay. Later, I'm going to show you how the ransom note was displayed in your machine. Okay. Let's talk about bootable disk. When we talk about bootable disk, usually in order for Petia to know what kind of disk that you are using, because it needs to know if you're using an MBR or if you're using a GPT. Why? Because MBR, it just need to override your MBR. Okay? If it is a GPT disk, it needs to override your your MBR, your second sector, and the last sector. Because the second, remember the second and the last sector is the GPT headers. So it's going to use this one, the device I/O control. Okay? In the device I/O control, you will be able to know if it is a logical drive or a physical drive. Okay? You will be able to tell if it is drive C or other drive. Okay? The initial call, Petia malware calls device I/O control twice. Okay? The first one is to check if it can access your hard drive. If it cannot, okay, it will just skip the infection. Okay, make sure that, okay, to avoid Petia infection, actually one of the things that you have to do is to make sure that you don't have admin access to your machine. Okay, if you don't have admin access to your machine, like you're just a regular user access, it won't be able to touch your hard drive. Okay, but most of us, when you buy your computer, okay, automatically your first login is actually an admin access. Okay, you might not know, but it is always something like that. Okay, so it checks if what kind of partition that you need. Okay, and then it checks if it is accessible. If it is not, it will skip. If it can access by using create file API, then it will proceed on the next device I/O control check. Okay, but first, how do you check if it is drive C? Okay, there are different names for the drive C, the very first drive. Of course, Petia is assuming that your first drive or drive C is your bootable drive. Okay, so for backward compatibility, okay, we can check if it is DR0. DR0 is actually your first drive. Or if it is Windows NT, you're looking for device hard disk 0, partition 0, or equivalent to DR0. Okay? Or you can also use legacy name, okay, using global and physical drive 0. Usually with the 0, you know that it is the first drive. And the way to access that programmatically is you just need to use create file. Because like Linux devices, everything is a file. Okay, for this one, in your Windows system, you can access your physical drive 0 or your drive C using the same function in which you open your file. Okay, create file A. There is a tool again in Windows system. Okay, you can use WinObj, this one, and then you can actually check, okay, what is the way your particular Windows version is naming your hard drive, and then you can probably do your checking. Okay, this is how the malware. This is the part of the malware code. It is now going to check. It is checking if your drive is your drive C, and then it is checking for device I/O control. This one, the second device I/O control API, is to check this one. What kind of partition? It is going to check if it is an MBR, okay, because of this code. Okay, it will know if it is an MBR, a GPT, or just a regular hard disk, the right type raw. Okay. There is a tool. Oops, what happened? Oh no, I'm infected. We're done. Technical difficulties. Okay. I'm just extending the time so that you cannot ask questions later. It automatically cuts itself in the middle of the talk. See, I already used up my time, right? Where am I? I think this one. Oh no. It's too far. Where did they go? WinABJ, physical drive. This one. Okay, there's a tool we call the process monitor. Okay, you can actually download that from sysinternals. Okay, you can get actually lots of different tools in sysinternals. Okay, you can run the malware. For example, you have the malware, you have the Petia. Okay, you want to monitor if it is really going to infect your hard disk. Okay, you have to run this tool. Okay, process monitor. It will tell you if it is going to access your file. Okay, using the create file API. Okay, and now it is checking your first drive. Okay, and then device I control is being checked. Okay, normally process monitor will give you lots of different information. This is already the clean version. Okay, and this is getting your information. But never ever execute the malware in your machine. It is not recommended to infect yourself, right? Okay, but if you're already infected, you won't be able to use the process monitor. You should have an isolated machine if you really want to check how the malware works. Okay, I'm not telling you to grab the Petia and then run it in your corporate machine. It is not my intention to say so. Okay, that is only the tool. Okay, let's go now how Petia actually read, encrypt, and overwrite your hard drive. Okay, first, it reads a copy of your sector, even though it doesn't matter if it is MBR, master boot record, the protected master boot record, or your boot sector. It reads a copy, it saves it somewhere else, and then from sector 01 to sector 22, it will produce this, it will execute this code, and each of those bytes will be XOR to 37. Easy, right? You can just XOR it back, you will be able to get your MBR. Is that simple? That is how simple it is to infect. Simplicity for this one, 37. Okay, and then after that, okay, after encrypting 01 and 20 up to 21 sectors, okay, it tries now the new MBR. The new MBR is actually the malware code, part of the kernel of the malware code. Okay, and then after that, it starts writing a small kernel code starting at sector 22. Okay, so MBR, partly, the main purpose of the new MBR is to load the kernel code starting at 22, sector 22 hex. Okay, how do you know if it is actually an MBR or a boot sector? Usually it is one sector, it is actually 0x200 bytes. Okay, the last entry should be 55 AA. If it is not 55 AA, that means it is not a boot sector, it is not an MBR. How does it look like? It looks like this. Okay, this is a dump of my boot sector, my MBR, and then there is a marker here. Okay, at the 200 hex bytes. Okay, there is a 55 AA, right? And then again, you can use the process monitor tool in order to check if it is actually infecting your hard drive. Look at this. This is the size of the sector. Okay, there is another tool. Okay, it is not from Windows. It is not from Microsoft. Okay, you can grab it online. I didn't put the link where to grab it. Could download it at your own risk. Okay, you can actually use HD Hacker. Okay, by this guy. Okay, you can actually read your content, the sector. Okay, you can specify which sector, you can specify the number of sectors here, and then you can save it, okay, to a file. Okay, but this is a very, very dangerous tool. Why? Because if you can read the sectors, you can also overwrite your own sector. If you click the wrong button here, okay, you will be able to destroy or to infect your own machine, even without running the Petia. Okay. Okay, again, this is from Petia. It reads this code. Okay, this is the tool from HD Hacker tool. So you're actually getting the same information. Okay, this is the code wherein it actually XOR. So it runs this one, create file, opens the sectors. infects the sector, so encrypt it with 0x37, and then write it back. So what happened is it read the sector from 01, XOR each byte to 37 hex, and then write it back to the same sector, and then read sector 2, and so on and so forth. This is what happens when you read the sector. See, it will look like this. 0x37 in ASCII is 7. Okay? And then again, you can again run process monitor. You will be able to see that it is actually reading, writing, and, oh no, there's no writing here. Oh, there's a writing. So there's a reading, writing, and so on and so forth. It is actually going to, this is now the process. If you see this, okay, you are now, Petia now is in the process of encrypting your drive. Okay, so this is the part where it writes the new MBR. If you can see, okay, this is the original or the old MBR. This is the Petia MBR. This is the loader, actually, of its kernel code. Actually, if you want to make your own kernel code, you can actually follow how Petia does it. Okay? You can learn something from the malware itself. Okay, the author is actually really, really cool. No, I don't know him. It's not me, it's not me. Okay, so this is the new MBR code. The new MBR code will look something like this. Okay, if you disassemble this, it will be like CLI and so. Actually, this is the start of, if you look at the boot process code, it will look similar like this. Okay, this is now the new MBR. Okay, it is downloaded from HD Hacker, this file. Okay, what happens? Can you be infected if you're using an MBR? How about GPT? Okay, because they are using both, they're still using, Petia doesn't care if it is MBR or GPT. As long as it can access your drive, okay, both of them will be infected. Okay, it doesn't matter if it is MBR or GPT. The problem is, if you are running an MBR code before, when you reboot your system, you will automatically see the Petia ransomware, okay, the ransom node. Okay, but if you are running GPT with UEFI, if you're infected with Petia, you won't see anything because the GPT or the UEFI will not be able to load the MBR. Okay, it will become a regular MBR partition. Okay, if you're infected with Petia. Okay, so you will know if you're infected if your machine doesn't start anymore. Okay, it probably other malware. Okay, this is the part wherein you can actually read the code. Using HD Hacker again, you can actually download the kernel code. So infect your machine, and then infect your isolated machine, and then you can grab the code starting at sector 22. Then you can now read the Petia kernel code. Okay, it's something like you're making your own Linux or you're making your own Windows. Okay, remember that when you turn on your machine, okay, the hardware itself still doesn't know if you're going to execute Linux and Windows. Of course, you know that you're going to use Linux. You know if you're going to use your Windows, but the machine itself doesn't know yet. So it should boot and run the sector, the very first sector, and then from that, it will decide, okay, whichever is, that's why you can have a dual boot. Okay, you can choose from Linux, you can choose from Windows, and so on. Okay, that is this one. The original, the first kernel code, okay, is the one that will decide which one is going to be executed. But if you're infected with Petia, okay, the first kernel code is actually the Petia kernel code. Okay, this is how it looks like if you're already infected. Starting at sector 22, you will be able to see the ransom node somewhere here. Okay, if you dump it, it will be something like this. Okay, and this is, if you're already infected and you want to pay, you will be able to see, okay, the onion address. Okay, I removed some of the characters here, so you don't need to pay for me. It's okay. Okay, what is the very first thing that happens when you're infected with Petia? When you're infected with Petia, okay, your master boot record will be overwritten, encrypted, and whatever. There will be kernel code. But how is it going to execute? Because if you're already running your system, you won't be able to know if you're infected with Petia until you reboot. Okay? You can still, when you're infected, you can still run your machine. You can still do your whatever you do, whatever you like using Word, Excel, or whatever. Okay? But once you reboot and then you're already infected with Petia, what happens is it will run the kernel code. It will run the malware itself. But don't worry, if you're infected with Petia, it will reset itself. So you don't need to reset. Okay, it will first get and escalate the privileges, okay, using these APIs, okay, and then it will execute this API, the anti-race hard error. Okay, once you execute that, it will automatically reboot the system for you. Okay, once it is executed, that is now the first payload. Once it is executed, okay, it is something like the file, the malware itself, the executable will now transfer the execution to the MBR, to the master boot record. So now it resets the system. Okay, now we're going to know to see how it works, how we can try to reverse. Have you tried reversing or analyzing the master boot record, boot sector? What tool did you use? Did you use this one? Yeah? BOSS, I don't know how to say it, box or botch, okay? It is actually designed to emulate a DOS application. Okay, for example, your Windows, you want to play your favorite Mario Brothers DOS application, okay? There's no way to run it because it's probably not gonna run on your system. Okay, you can run this using this one. You can download this one for free, okay? And then you can run your system with that. But this one, I didn't use it to run Super Mario DOS version, okay? I use it to debug the master boot record, okay? Okay, this one, the box, is actually can simulate your Intel x86 computers, okay? You can run all those programs, okay? And now you can use it to debug your master boot record, okay? It doesn't matter if it is infected or not. You can just infect it, okay? Or you can just debug it, okay? Okay, for this one, for this particular infection, okay, I executed box one by one, instruction by instruction. I executed it like 5 million steps in order to go to 7C00. That is the very start of any operating system. That is the time it is going to decide which operating system it is going to use. Okay? So maybe if you're going to execute it on your own machine, it's probably a different number, but I specifically execute this one. So I think it took me 2 months to press it until I finally find the 7CCC. I'm just doing that for 2 months. Okay? That's my job. Okay? And then you will be able to see the very first sector loaded at 07C00, and then that's actually the Bootstrap. The Bootstrap is where it decides which kernel it is going to execute. See, look at my hands now. Just kidding. Okay, this is now the new MBR. The new MBR, okay, if you reach 0x700 location or offset, okay, you will be able to now execute this one, okay? The only problem with box, this is now how the box looks like. This is the emulator and the debugger itself. Okay, the only problem with this one, if you're familiar with Oli debug or Immunity debugger, it is user-friendly. You can just, every time you move something, instructions, automatically the rest of the windows follows, right? But this one, using box is very hard because every time you execute something, you have to refresh this window and this window because it doesn't actually totally follow you, right? Okay, if you want to, this is the one that I press. Okay, you press C, okay, 5 million times, you will be able to see your code. or 7C00 execution. This is your register windows. This is your dump window. This is the one that you have to refresh every time. And this is your code. The only problem with this one is if you're used to analyzing or reversing Windows application, okay, there are APIs. Okay, APIs like readable instructions. Okay, for this one, there's no APIs yet because it doesn't know yet if you're using Linux or Windows, right? So it only uses interrupts. Have you created a program using interrupts? Assembly language. Okay, this one. In order to read the functions, or for example, you want to change the video mode, you have to use interrupt 10. If you want to do some readings of the version, extended read sectors, you have to use function 42, okay, interrupt 13. In order to do that, all you have to do is to set up the registers. That is how you program in assembly. You set up all the registers, the values, and everything, and then execute interrupt 13. It will be able to do your functions. Okay? Okay, this is the format we're in. Okay, this is the content of your boot sector, part of the boot sector, wherein this is now where it tries to transfer your MBR. It tries to, in fact, this is how Petia reads the part wherein it will read sector 1, encrypt, and write it back, read sector 2, and so on and so forth. Okay? This is what we call the DAP, the disk address packet. Okay, for Petia's code, these values are the very first one. This is now the very first part or value of this one in order to read your MBR. Are you still awake? Sleeping. If you want to read, okay, where are we? Okay, if you want to read this one, it reads 200 bytes from sector 22 and so on and so forth, okay, in order to hide the MBR. Okay, this is where it transfers when it runs the MBR code, it gets the 22. Remember that the sector 22 contains the kernel. It transfers it back and then jumps back to that one and then execute the kernel code. This is now where it starts executing its kernel. Okay, again, some of the challenges of debugging the MBR, the master boot record using Box is, okay, the dump is not interactive. You have to keep refreshing it. And then, of course, you cannot put like labels and comments. Let's now try to initialize some video screen. All you have to do is to run interrupt 10 and then change it to these values. Those are some of the codes in Petia. Okay. This is the part where it tries to copy the MBR. And also this one, this one contains the Tor addresses. Okay. If you see Tor addresses in your sector, in any sector that you have, okay, you might be infected with Petia or infected with some malware. Okay. This is the one that it reads the sector. The only problem with this one is this particular byte in your boot sector, in your master boot record, is the encryption marker. Okay. Petia will check if that byte or that marker is 0. If it is 0, that means your MBR, the rest of your MBR, is not yet encrypted. Remember, it encrypts your MBR using 37 hex, okay? But it is going to encrypt the rest of your hard drive, okay, using a different encryption. I think it's using Salsa 20, okay? And then if it is 0, okay, it will start encrypting the rest of your MBR. And then if it is 1, it will stop encrypting. It will show you the ransom node. Okay? There is a risk on this checking. We'll show you later. This is the initial display wherein if you run your Petia in the kernel code, okay, you will see something like this. It is an output of like a DOS tool. Do you know what tool is this? Anybody? It is a check disk. Okay, it looks like a check disk. Okay, because it's like going to this. Before, when you're trying to like reset your machine improperly, it runs this, or you can actually run this on your own to check if your disk is still in good condition. Okay, so Petia is actually using the same display or the same strings, okay, in order to try to fool you that it is checking your disk. Okay, this is the code wherein this part of the code is the one just displaying the bytes one by one, displaying the strings one by one. It is part of Petia kernel code. What happened? So this is just displaying those codes. Okay, and then again, it checks for the encryption marker. If it is 1, okay, it is already encrypted. If it is not, it will start encryption. What happens? Okay, this is the part wherein it gets the sector that it wants to encrypt. Okay, but Petia, unlike some ransomware, most of the ransomware that we know is actually encrypting your files, right? You get they get the files, they encrypt it, and then once you pay the ransomware, okay, ransom note, and then they will try to give you the decryption key. But this one, for Petia, it is not actually encrypting your files. Okay, it overrides your master boot record, but it is going to encrypt your MFT, the master file table. The master file table contains the headers of your files. Okay, so if you have 100 files, those 100 files will contain an entry. Each of them will contain an entry in the MFT, in the master file table. Okay, so Petia is not encrypting your file, it is encrypting your MFT. That means if you're using some forensic tool, okay, for example, you're already infected, you can use some forensic tool to brute force, okay, to grab each file. It may not have the proper file name, but at least you can still get your files. That is this version. Maybe the other versions are already encrypting the files. Okay. The next set of display is actually, it is going to display this value here. Okay, check this is repairing sector. This actually repairing part is actually the infection part, the encryption. Okay, and this one is actually the number of sectors that the MFT is occupying. Okay, actually the computation here is actually precise. It depends on your number of sectors that contains the MFT. Okay, it is going to infect your file or the MFT, the headers. Okay, so this is a typical MFT entry for a single file. Okay. After infection, it will look something like this. Okay, take note that this is not encrypted using 0x37. It is encrypted with Salsa 20 with its own other keys. That's why you need to have the key to decrypt. This is how it tries to encrypt your MFT. Okay, these are the codes that it uses. Okay, it's just using again, still using some interrupts inside those calls. Okay, it will start counting. Those counting is actually when it's tried to infect each sector that contains the MFT. So this is a typical, see, I have to refresh every time. That is the typical MFT entry. Okay, after executing that function, it will actually be encrypted. Okay, refresh again. Okay, that is now your MFT. That is now your entry. It is now encrypted. Okay, it will start going to do the same thing over and over again until it finally encrypts the whole MFT. The problem is, once you see this particular part of the infection, okay, if you're in the middle of this one, okay, never ever terminate or turn off your machine. Why? Because if it happens that it is not yet complete, if you're in the middle of it, for example, it encrypts 50%, and you might think that you can actually get away with it, but the problem is, if you're infected with 50%, okay, and then you decided to pay the ransomware, okay, what happens? The ransomware, if they are going to give you the key, remember that they will give you the decryption key. Okay? Your decryption key will decrypt the 50%. What happens to the other 50%? Your decryption key now is the key to encrypt the rest of your 50%. Remember? So that's why when you see this happening, never ever stop your machine. Just let it go. It's done, right? So that when it's time for you to decide to buy or to pay for the ransomware, okay, at least your decryption key will be able to decrypt the whole thing, the 100%. So keep in mind, if you're infected with Petia, okay, you have to complete. I'm not endorsing the malware. Okay, so make sure that you are in the process of. It should be able to encrypt the whole thing. Otherwise, you will have a half-baked MFT. Okay. Okay. After the encryption, for example, we decided to let it go. Okay, and then the malware will actually do a second reboot. Okay, it will execute a second reboot. Okay, in order for you to check. It will check again. Okay. If it is now encrypted, it will check the infection marker. If it is 1, it is already infected. That means it will now show you this one. Okay, same thing. It doesn't have an API. It is actually outputting or displaying it byte per byte. I just output it per line. Okay, so it is going to display this famous ransomware screen. Okay. It is going to do the blinking, right? There's a different version of Petia wherein you can see a green skull, I think, and there's a white version, I think, and then it will just flash the screen, right? Flash it on the screen. Okay. If you have the key, for example, you pay because you are rich. I don't know why you're paying. Okay. If you pay, take note that it is not 100% guarantee. Any other ransomware, it is not guaranteed that they will be able to give you the key. Okay? Otherwise, you're just paying for nothing. Your best defense is still back up your system, right? So this is now your infection. So after the second reboot, the malware will know that it is already infected or encrypted. It will ask you to pay here. Okay? You have to give this information. Okay, this part is actually I'm trying to test if I can guess the key. Okay, I tried my name, didn't work. I don't know why. Okay, I tried something, didn't work. Okay, I think I was able to actually guess the key. See, I tried it again using my name. See, I'm still debugging as part of this, okay? And then afterwards, after a certain time, you will be able to see this, okay? It is now going to decrypt the same sectors, okay? But that one is not actually true, okay? Because I am debugging, I actually just jumped to the part where it is going to show you that it is decrypting, but I was not able to guess actually the key, okay? And then if you're successful, it will ask you to reboot your computer, and then you'll be able to have your computer back, I guess. Okay, for Pinale. For stage 1, okay, that means you're going to execute the Petia executable. It copies MBR, put the mini kernel code to the hard drive, then reboots. Okay, stage 2, okay, displays the fake, check this, encrypts your MFT, initiates the second reboot, okay, displays your skull, okay, and waits for your Bitcoin payment. If you want to pay, I can give you my Bitcoin address or wallet just to check if it's going to decrypt, okay? And these are some of the tools that I use. And of course, the box debugger. And I think that's it. Thank you. Thank you for staying.
Thank you. Very pedagogical description of the whole process. Thank you.
Thank you.
So, do we have questions for the audience? From the audience? Can we get a microphone there?
Are you still awake when I'm doing the debugging? No.
Well, I'm awake at least.
Thank you.
Sorry if I missed that part, but how is the key actually generated? Is that during the phase when it's infecting it, it's sending something to the store services, or is it the same key for everything?
You mean when you pay the ransomware and then when you get the key?
Well, it need to be encrypted to some specific key, I guess.
Yes. So what happens is once the Petia is done with the stage 2, okay, it's already showing the blinking skull, it will give you, remember the part where it gives you the onion address, and then you will be able to go to that onion address and then give the information for your particular machine. And then if you're lucky, you will be able to get the decryption key. And then remember the part where I tried to guess it with my name? That's where you put your decryption key. And then if it is right, it will be able to decrypt your
I think the question is.
Oh, sorry.
I think the question was when it's generating the key to encrypt it.
It is generating a public and private key. Okay, it generates the private key, and actually it sends the public key will be on the private key is actually for the one that will be given to you from the website the onion website.
But it's generating the keys.
It's not going to generate the key while you're being infected.
So everyone gets the same key.
Everyone gets the you get the public key, but it will be mixed with the information for a specific machine. So even though if there are two machines infected with the same public key, okay, once you ask the Petia author, it will give you a private key only for your specific machine.
All right.
What's the seed for that?
I don't actually know. It's using Salsa 20 algorithm. Asymmetric cipher. I didn't actually go into the actual algorithm, but it should
the
be,
actual encryption is probably symmetrical because it's a lot faster. So there's probably a hidden key that's encrypted.
No, I think it's not. You will not be able to find the key inside the malware itself.
No, of course. Any more questions from the audience?
Hello? Is it possible to put the physical disk into box and just jump to that decrypt me place and recover your stuff?
If you're saying if you are infected with your hard drive is already infected, and then put it in another machine to analyze.
Yeah, and then get box to read the physical device, and then tell it to jump to the program where it says that it's decrypting. So you could just bypass the whole thing.
No, I don't think so. Yeah, because once you are infected and then you actually run it with the same hard drive, it will still ask for your thing. That's the problem with the Petia ransomware is if you're a home user, you're infected, mostly you only have one machine, right? So there's no way actually to go to the onion address. You have to go to your neighbor, okay, to go to the onion address and then get the decryption key, okay? But if you're in the corporate setup, you have lots of machines, or probably if they are not yet infected, then you can do that one. You can get the decryption key. But the problem is if you just bring the hard drive to an open box, it will still execute the ransomware. Unless you have it as a slave drive, okay? You might be able to probably analyze. Yeah. Oh yeah, that's why if you put it in a machine and then you put it as a slave drive, okay, make sure that you don't actually boot on that machine, on that drive, then you will be able to analyze.
but not decrypted because you don't have the key. All right, more questions?
If you're infected with the same variant of this one, because it doesn't actually encrypt the whole hard drive, you can brute force to get your files. You can brute force the whole drive to grab the files itself. Just put the rename those things. Yeah, you still be able to get the files. Question?
All right, then thank you very much, Alvarez.
Thank you.